All right, well, welcome everybody. I'm Tyler. I'm an instructor here with Manhattan Prep, and this is a GRE prep hour. We do a couple of these every month, and it's just an opportunity to check out some free content. I and every other instructor here at Manhattan Prep has scored in the 99th percentile of these tests we teach. And yeah, we are all kind of big nerds and we enjoy dorking out about this sort of stuff. So I'm excited to spend the next hour with y'all. And we are going to take a deep dive into absolute values. If you would in the chat, everyone let me know, where are you in the world right now? I'm coming from Brooklyn, New York. So, if anyone else is in New York, hello. Maybe we got some others in Eastern time. Haley is in Brooklyn too. Awesome. I'm coming from Crown Heights right now. Well, we got a couple of Brooklyners in here. Yvonne as well. Great. Well, wherever you are, welcome. Let's go ahead and get things started here with a quantitative comparison. So in that chat box, I want you to take a look at this problem, and then we'll take a couple minutes, and then chat me what you think the answer is. Okay, so this one's a little trappy. The reason it gets trappy is because there's this common misconception that absolute value makes things positive. But that's a relatively naive definition. Isn't always the case, because something like n is greater than 0, that is not a universally true statement. I have to modify one thing here, is that it is greater than or equal to 0, because the absolute value of 0 itself is 0. So our answer here, this one cannot be determined. If y is positive, it'll be bigger, but if y itself is 0, those two are equal. So not a consistent relationship there. So first big piece of info, just the definition of an absolute value. At minimum, it is 0. Okay, let's take a look at another problem. Chat me your answers for this one. So one way I could go about solving this one is to pick some values. So if I say x is 0, then I've got my absolute value of 0 minus 1 versus 1 minus 0. You can see where that's going. We're going to get 1 is equal to 1. I could try x is equal to 1, try some other simple numbers. No matter what we're going to do here, these two are going to end up equal to each other, and the answer is C. And what I want to do is make this relationship more obvious so that we don't even have to test numbers at all. It's just clear the absolute value of x minus 1 is equal to the absolute value of 1 minus x. And what's going to help with that is this understanding that absolute value is all about distances on the number line. Like, forget this idea that it makes things positive. One, that's not true. It could also be 0. The main idea here, it's about distance on the number line. So you see something like the absolute value of -3. That's the distance between -3 and 0 on the number line, right? A total of 3 units of distance. Or if we had something like -4 minus 2, the absolute value of that, it's already giving me the endpoints there, right? I'm just comparing -4 and 2, the distance between those 2 points on the number line. 6 units of distance between them. Where this gets a little bit tricky is if I have addition inside the absolute values. Understand that distance is inherently a subtractive relationship. So if I have something like 3 plus 2, this method's going to make more sense if I just rewrite that as a subtractive relationship, as in 3 minus -2. And then we see, oh, this is the distance between -2 and +3 on that number line. So I encourage you, whenever you're thinking about absolute values here, conceptualize it with this subtractive relationship, right? If it's just a value by itself, implied there's a -0 that could be written there. If it's given to you subtractively, great, like that's the easiest form. If they give you an additive relationship, rewrite it as subtraction with the negative, and that's going to tell you exactly what are the 2 objects on the number line that you're finding the distance between. So to back up to the previous problem we just saw, the distance between x and 1 has to be the same distance between 1 and x. If I ask you, what's the distance between LA and New York versus New York to LA, it's the same distance. Whether I go from A to B or B to A, that has no bearing here. So that's the kind of more conceptual number line type approach I like to take on a lot of these. But sometimes there's no way around just kind of doing the algebra. So it's important to understand how those solutions look as well. So let's quickly walk through that process with an example here. So if I start with something like the above, the first step of the process is you want to isolate the absolute value, get it by itself on one side of the equation. So in this instance, subtract 2 from each side. Then I'm going to want to divide by 3, and then boom, I've got it isolated. From here, we're going to break it up into 2 cases. Because recognize the contents of that absolute value. It's either going to be the case that the contents are positive, in which case I can just drop the absolute value signs and get the same equation, or the contents are negative, in which case applying the absolute values to a negative makes it the opposite of what we were looking at. So applied to the algebra here, I'm just going to drop the absolute values and insert a plus sign, and also do one where I insert a minus sign, representing that opposite case if the contents were negative inside. And then from there, just distribute the positive and the negative across. And we're going to solve out for x, and we get our 2 possibilities. That x could either be 0 or -10. How are y'all doing in the chat? Let me know if anyone has a question about this idea so far. Okay, go ahead and try this next one on your own. Chat me what solutions we have for x here. Okay, let's check out the solution here. So again, first thing we want to do is just isolate that absolute value. So then we've got x minus 4 is equal to 11. Second thing we want to do is break it up into two possible cases, right? Either those contents are positive or those contents are negative, so the absolute value makes it the opposite of what we had inside. From there, I'm going to isolate and solve for x. So two possibilities, it's either 15 or -7. And note, even if this were an inequality rather than an equation, this same process would hold. There's just going to be one extra step in one of these cases that you break it out into, where you're going to have to multiply or divide by a -1, and that's going to swap the direction of the inequality around. Whenever we multiply or divide an inequality, the sign's direction will flip. So if you're working with an absolute value inequality and you break it into two with this logic, that's going to more than likely happen to one of these when that process takes place. But thinking back to the number line, I want to encourage you to think less and less about algebra and more about what this means in terms of our number line here. So the absolute value of x minus 4 is less than 11. So let's say that's 4 right there. What this information is telling me is that x can either go 11 units higher or x could go 11 units lower than that 4. And that makes sense with this range that we found here, because 11 units lower is -7, 11 units higher is 15. That's where I can place x within this range. Okay, let's look at another one. And I don't want you all to solve this one quite yet. I just want to ask this question. Given the setup here, what answers could I eliminate right off the bat? Give you a hint, it has to do with this definition we talked about. An absolute value is 0 at its smallest. So we're looking for a value of x. Which one of these answer choices can we eliminate? So recognize the absolute value of y is less than or equal to -4 times x. So if x were choice D or E, I'd get this statement that absolute value of y is less than or equal to some negative value, which we can never have. The smallest an absolute value can ever be is 0. D and E would give us a situation where the absolute value is negative. That's impossible. So right off the bat, you can get this one down to a 1 in 3 chance. And depending on where you are in the exam and how much mental fatigue there is, how much time you have to do a certain question, anytime you're making eliminations, you're making the right moves. And sometimes it behooves you to just go with one of those 50-50s or 1 in 3 guesses, then put in the full time and effort to do a full problem. Let's keep trucking along here. Let's look at a new one. Here's another quantitative comparison. Try this one out. So if I think about the algebraic approach here, I'd want to split up that upfront info into two cases. We've got the positive possibility and the negative possibility. And then I solve out and I get x could be 2 or x could be negative 4/3. So it seems like x could be greater than or less than equal to 1. So I might go for answer choice D. But that is actually a big trap answer here. Why is that? Why is D a trap? Think about that for a second. So look at these results we got. X is either 2 or X is this negative number. And recognize if X were that negative number right there, I would have an absolute value equal to a negative, and that can never happen. So this is something called an extraneous root. The only true solution here is that X is equal to 2, which makes quantity A bigger than quantity B. So answer would be A here. As far as the GRE is concerned, there's really 3 situations where you might encounter an extraneous root. One of them is, like we saw here, where we have variables both inside and outside of the absolute value symbols. Another situation where that might arise is where you have variables both in and out of an even ordered root, like a square root or a fourth root. And this third situation is that we have a variable in the denominator. The reason you want to be aware of extraneous roots here is there's certain mathematical assumptions being made in these cases. Right? By definition, whenever we're working with absolute values, it has to be true that the absolute value of n is greater than or equal to 0. So after getting these solutions, I have to double check and make sure I haven't violated that rule at any point. Likewise, if we're talking about roots, if I have the square root of n, that can never be negative. Always has to be greater than or equal to 0. So if I've got a problem where variables are both inside and outside of that radical, I got to be very careful that I haven't violated that assumption. And then finally, if I have a variable in the denominator, it just must be true that n cannot be equal to 0. Division by 0 is undefined. So if you ever encounter these 3 cases, beware of those extraneous roots. Sometimes the algebra can lead you to a false answer. So you just want to plug it back in and make sure you didn't violate any mathematical definitions. Okay, let's try another quantitative comparison. I'll give you a few minutes with this one. First place I'd start in this problem with our upfront info at the top. Knowing that the absolute value of x minus y is less than 0, that's kind of a strange thing to wrestle with. But I think what makes more sense is if we add y to each side, I get that the absolute value of x is less than y. And I think that starts to really unlock what's the relationship going on here. So if I consider a number line, remember that the absolute value of x has to be something positive, and it's positive or 0. So let's just kind of like arbitrarily plot it right there. There's my absolute value of x. And that is smaller than y. That is, it's to the left of y on the number line. So that means what either is going on here is that x would be right there because it's positive and negative x would be over here, or it's the opposite case, that x itself is negative, in which case its absolute value is equal to its opposite. Y, on the other hand, it's bigger than the absolute value of x. So when I think about the opposite of y, it's going to be the same distance that y is from 0, but going in the other direction. So using this kind of visual number line approach, I see x is either going to be negative and bigger than the opposite of y, or it's going to be positive, but also bigger than the opposite of y. There's no two ways about it. Quantity A has to be bigger. So didn't have to pick numbers or use too much math. I could just think about this logically and visually, understanding number lines and what absolute values mean. I want you all to check out another number liney problem here. All right, let's take a look here. I want y'all to think about this question. What happens when we cube a fractional value? So if I cube a positive fraction, it's going to decrease, right? If that's z cubed will move in like that. If I cube a negative fraction, it actually increases. But what we can say sort of universally here is when we cube a fraction, it gets closer to 0. So whether it's positive or negative, it's going to move in on that number line towards that 0 point in the center. So z cubed, it's going to be smaller than z itself. W cubed is going to be bigger than w itself. But then look at quantity a. We're subtracting 1 from it. So I'm never actually going to become positive when I cube that w. It's always going to be some fractional value a little less than 0. But then if I subtract 1 from it, right, we're just going to back up 1 unit on the number line. And that's going to put us in this range where we're a little bit smaller than -1. And then if I take the absolute value of that, we're going to move to this side of the number line and end up around here. So basically z cubed, that's always a positive fraction. And w cubed minus 1, that's always some positive value bigger than 1. So no matter how you slice it, quantity a is the bigger of those two. Let's mess around with this problem a little bit more. I'm going to change some of the values here. If we got rid of z entirely, and we made this just w, and I changed quantity b, how does that affect the answer? Try this new one and chat me. So if I square this negative fraction w, it will become positive. So w squared is going to be something like that. Closer to 0 than regular w, but squaring a negative always turns it positive. From there, if I subtract 1 unit, w squared minus 1 is going to end up somewhere like that. So the absolute value is going to be somewhere around there. So again, quantity B is always a fraction between 0 and 1. Quantity A, nothing's changed there. It's always got to be something bigger than 1 itself. So that makes quantity A the bigger of these two. Another concept you'll want to be familiar with is how to represent these ranges on a number line using this notation. So this range has a maximum and a minimum. So I can easily get rid of A, I can get rid of E, because those would kind of keep going on forever in one direction. And I got to restrain it on both directions. And then recognize when we have these multi-part inequalities, I can take the same action to each region here. So isolating for X, I would divide each region by 2, and then we get -3 is between X, or X is between -3 and 1 rather, and that's exactly the range we've got there. So B is going to work. C comes close, but you'll actually get -3 is between X and 2. Not exactly what we're looking for. D, taking a look at, you can tell that one's not really going to do it for us either. And then for F, here, remember, think about that definition, that subtractive definition. Rather than using x plus 1, I want to use x minus -1, which is literally telling me the distance between x and -1 is less than 2. All right. There's our -1 right in the middle. I can go 2 units to the right. I could go 2 units to the left, but I have to stay within those 2 units. So F is telling us exactly what we need. G would be the distance between +1 and x. 2 units to the left or 2 units to the right of that. Not quite what we're looking for. Okay, this next one may not seem like it's about absolute value at the outset, but be careful. Try it out. Okay, it's so easy in this one to say to yourself something like, okay, if x is equal to 5, quantity B is 5, quantity A is the square root of 5 squared, so the root of 25. So it seems like those two are equal. But remember, don't always stick to positives. This test loves to throw in these sort of gotchas, where if you forget about negatives, they're going to get you every time. So if x were -5, quantity B is -5. Quantity A is going to be that -5 squared. -5 times -5 is 25. The square root of that is 5. And then we see these two are definitely not equal. I have a +5 versus a -5. So 2 different relationships. The answer has to be D. So the way this pertains to absolute value is if I have the square root of something squared, it doesn't produce x itself. It produces the absolute value of x. So that's what happens when I'm using an even ordered root in power, like a square. If I take the same problem and we change it to a cube root and a cube, does that change my answer? Chat me what you think. So if we've got the cubes this time, those two are equal. The cube root of x cubed is just x. And the way I could put this more generically is if I have x to the nth, and then I take the nth root of that, well then if n is even, that's going to be equal to the absolute value of x. But if n is odd, then that's the case we just looked at. It's equal to x itself. So careful with those even ordered powers and roots. They can behave a little counterintuitively sometimes. Okay, we got a few more to do here tonight. Try out this fill in the blank problem. First thing I'd like to do here is looking at that first absolute value, x plus 2, rewrite that in the subtractive form. So x minus a negative 2. The distance between x and the negative 2 has to be within 5 units. So now I think about my number line. There's 0, there's negative 2. I can be 5 units to the right or 5 units to the left. Those are my possible values for x. For y, it's already subtractive. So the distance between y and positive 2 has to be within 8 units. So I could go 8 units to the right. That would put me at 10. Or I could go 8 units to the left. That would put me at negative 6. The trap with these problems is that people are always going to focus on the positives and do something like 3 times 10. But that is not the greatest possible value, because look at the other side over in the negatives. If I multiply the negative 7 and the negative 6, multiplying 2 negatives will yield a positive, and that positive is bigger than the one I get with the 3 and the 10. So 42 is the biggest it could absolutely be. As an aside, what's the least possible value for xy here? It's not 0. 0 is a small value, but I could get something less than 0 if I multiply the negative 7 and the negative 10, kind of going coast to coast. My furthest negative value and my furthest positive value, that's going to get you negative 70. If they had asked us, what's the least possible value or the absolute value of xy, then that's 0. We can never have an absolute value smaller than 0 itself. Okay, try out this tricky one next. So I think my preference with this one would be to do a more algebraic route. And I usually lean that way if it's like a 2x or a 3x inside the absolute values. I stick to the more number line approach if it's just like a single variable. But as soon as the coefficient gets higher than 1, that can really send your brain for a warp here. But doing our algebraic approach, the absolute value is already isolated, so I'm just going to break it into my two cases. So the positive and the negative, solve that from there. And I'm going to see that x has to be in between this range of -15/2 and 9/2, or as a decimal, between -7/2 and 4/2, or I'm sorry, -7.5 and 4.5. And then there's this subtle piece of info here that x has to be an integer. So within that range, there's only so many integers. That x could be anywhere between -7 and +4. So D isn't going to quite cut it because it tells us that x is always less than 4, but really it's that less is less than or equal to. So if they had added just like one line there, D would work, but D is a subtle trap. It is not quite what we're looking for. C, on the other hand, for all of these potential values, it is true that x is always greater than -8. And that is the sole correct answer here. So the takeaway is read carefully. Be on the lookout for a less than versus less than or equal to, or the opposite. Very subtle, but I've seen those traps come up on the real exam. Okay, let's check out one more challenging problem and then we'll wrap up. So our number plot's going to look something like this. The absolute value of xy is less than y. That's another way of saying xy is closer to 0 than y. So then you need to ask yourself, what could x be if xy is closer to 0 than y itself? What kind of number or numbers could x be in this case? Well, if I'm multiplying and the result moves closer to 0, x has to be a fraction. It could be a positive fraction or it could be a negative fraction, but multiplying by either is going to move that result closer to 0 than the original was. In other words, x is between -1 and +1. So rather than test out each of these problems, each of these answers individually, much faster to just recognize that, look at your choices. There's only 3 possibilities in that fractional range we're looking for. So E, F, and G are our answers. All right, so that about wraps it up for today. I'll show you some takeaways here in a second. But I'll ask you all, take a moment here just to kind of pause and reflect and think about what were some ideas from this lesson that you're going to continue to work on and continue to keep in mind as you study. All right, I'm seeing some great stuff in the chat. So remember, absolute value is not just about positives. That's the naive definition. Remember that it could also be equal to 0. Don't let them trap you with that exception. And at its core, it's really about distances on the number line. Remember that if we define them subtractively, that's always going to tell you what are the 2 points being compared. Like C minus D, it's the distance between C and D on the number line. If you get that addition comparison, I think it's easier to rewrite it as a subtractive comparison with the opposite. So the distance between E and the opposite of F. If you're going to take the algebraic approach, remember, once you isolate the absolute value, you need to split it into the positive and negative case, and then solve out for your variable from there. If it's an inequality, anticipate that there's going to be some sign flip after you divide by -1. And some common traps to be on the lookout for. Beware those extraneous roots. If you have variables both inside and outside the absolute value, you have to make sure you respect the definition. An absolute value can never be negative. So plug those answers back in, make sure you haven't violated that rule. We saw that subtle trap a couple problems ago where it's less than versus less than or equal to. Very frustrating, but fair game on the GRE. Make sure you understand the difference and read very carefully if there's both of those being used in a problem. And this exponent rule I find really cool. That if we take the nth root of x to the nth, it's equal to the absolute value if n is even. We only return x itself if it's an odd root of an odd power. All right, and just some final plugs here. As mentioned at the start, I work here for Manhattan Prep. I'm an instructor. If you want to check out some of our free trial classes, we offer a 9-course GRE class. Session 1 is always open up to the public. So if you want to take it for free, like no expense to you, you can sign up online, check out session 1 for free. And it's not like a college class session 1 where there's a ton of time spent drilling the syllabus. we actually cover a lot of material in session 1. It's pretty jam-packed. So if you want to check out more of this instruction style, it's totally free. I encourage you all to go to that link, sign up, and check it out. If you're watching this on YouTube, we have a ton of other GRE prep hours, so subscribe to our channel to stay up to date on those. And that said, it was a pleasure hanging out with y'all this past hour. If anyone has a question or something they want to go over, feel free to stick around. For now, I'm going to end the recording.